Alright, so this is my second forces and circular motion reassessment video. What we have here is we have a car, a guy driving a car through some hilly country road, and he wants to know how fast he can go without getting airborne at point A or hill A. The car has a mass of 1,280 kilograms, and it's going to be going over a hill with a radius of 20 meters. So since it's a hill, we're going to assume it's a circle, and the acceleration is always inward toward the center of the circle. So it's got the gravitational force straight down, and then obviously the normal force straight up. So what we're going to do here is we're going to have F net equals ma. Since the normal force is the contact force, and since we're trying to figure out what the how fast he can go without getting airborne, we're going to find the velocity that he has to go to get airborne. Therefore, we can say, you know, as long as he goes less than that, then he will be okay. He won't get airborne. So since we're going to assume that he's getting airborne, we're going to say the normal force is 0 because he's not touching the surface of the road. So we're going to cancel that out, and we're going to get an equation of G equals V squared over R. We're going to move it around a little bit with some algebra and get it down to a little something more manageable, which is V squared equals radius times gravity. And we're going to get an answer of 14 meters per second. Now, what that is that's how fast he has to go to get airborne or to start getting airborne. So as long as he drives less than that, then he will be fine. He will not get airborne. The second thing we're trying to find is the force that the road exerts on the car. And the way we're going to find that is by using, again, the F net equals ma, basically one of the biggest, if not the biggest, principle we've learned in physics this semester. It's a huge part. And what we're going to do here is we're going to say F net is minus the mass times gravity, which is 1,254 kilograms, and then we're going to say it's equal to 1,280 kilograms times 17 meters per second squared over 43 meters. So we're going to get an upward force from the road on the car of 21,146.8 newtons. So that's a force from the road on the car when he goes into point B or hill B, which is basically like a bottom. So that's about it. So now we know if you have a hill of 20 meters radius, you know not to go faster than, or you can go up to 14 meters per second without flying off the hill, as long as your car is about 1,280 kilograms. So that's about it. Thanks.